Hi all, welcome back to our YouTube channel. Topic that we will have a look at today is from FRM level 1 and it's from Quants paper 2 from level 1 and topic is from machine learning and predictions and the topic is confusion matrix. And yes, we hope that you are utilizing your time effectively and you're studying well. And please do subscribe to our channel. Our channel can act as a catalyst to your studies. And please do share it with your colleagues as well who are preparing for FRM level 1 or CFL level 2. Quite of the common topics are also there. So let's have a look. So this is something that we will be covering today. First, we will see that what's the objective, what you should expect out of this video, and then understanding confusion matrix and then demonstration confusion matrix, followed by some application of confusion matrix. So, see, of course, there is a topic that we will be having a look, but there should be some output out of that. So, this is something that two cases are given to you, wherein case one is there is portfolio manager who has to make a decision whether to invest in a private equity or not. So just make a note that it's a private equity. And in a private equity, if you make a wrong decision, say for example, uh, you choose to invest. So say for example, my portfolio managers say that yes, we will go ahead. And if that turned out to be a wrong decision, then loss could be very high because private equity is kind of very high risk and high return. So yeah, that's something. So it is kind of a type 1 error wherein model was, I mean, the investment tool was actually not that good, but manager took a wrong decision of investment. So that's kind of a type 1 error. So from confusion matrix, we will be having a look various measurement tools. So for this case, what is a tool that is recommended to check this kind of model, a model which is making prediction of this type. So which is a measurement criteria that you would be focusing on. That's the case one. So best way to learn application is case studies. So these can be designed hypothetically to make your understanding well. And case two is, say for example, for jurisdiction system, uh, like I mean, you can imagine that uh, when there is some culprit and he has been categorized as I mean no culprit or he has been released. So that is a kind of type 1 error. There was a problem with the person. There was actually a criminal person, but due to some error, we ended up releasing him. That is a type 1 error. And type 2 error is penalizing some innocent person. That is type 2 error. So say for example, there is some person who is innocent, but because of some flaw, we ended up categorizing or classifying him as a guilty. So that is kind of a type 2 error. So over here, for me, it's more important to understand type 2 error. I mean, for me, it's very critical to be very mindful of type 2 error because it's very important that no innocent is held guilty. So in this case, what is the measurement criteria for a model that you will apply? So this is how. So if stay till the end of the video because trust me, it will make your type 1, type 2 error understanding also very thorough. So let's see what is a confusion matrix. And from confusion matrix, there are various tools to measure the model performance. So what are the model performance criteria that would apply to these two cases? So stay till the end of the video. So, confusion matrix is a tool used to evaluate performance of a model. So, it's a tool used to performance a model I mean, a model performance, I would say, in machine learning and data science. In these two spaces, the confusion matrix is used to measure the model performance and of course to make an informed decision and improvements. Because we want to improve, we need to have some measurement tool. So confusion matrix is one of the measurement tool. One powerful tool for assessing classification models is confusion matrix. So very important to know that it's mainly for classification model. So when we say classification model, it's kind of model that would classify in two categories: default, non-default, invest, don't invest, whether firm will issue dividend or no dividend. So classification. So classification in two categories mainly, not regression. So mainly the confusion matrix is a tool to evaluate performance of a classification model. Very important to note, if you are making notes, just make a note of this point. This matrix provides a detailed breakdown of model prediction, allowing practitioner to derive various performance metrics. So as we saw, as we are intended to evaluate what are the different things that we would apply to both cases that we saw. So it has various performance metrics that we will see in next slide. And yes, before we actually go into those performance metrics, let's see that what are few terms that would be we would be using when we will be making ourselves familiar with those metrics. So there are four categories. So true positive. When I say true positive, say for example, you have got, let me draw a box. So say this is a model which is being used to evaluate if the bond will default or not. So when I say TP, so when I say TP, it means that model predicts no default. Let me write default complement. And this is a model and this is actual result. So in reality also bond did not default. So that is called as a true positive. When I say true negative, model estimated that bond will default and it actually defaulted. So that's called as a true negative. When we say false positive, so it is a incorrectly predicting a positive instance. Okay. So when you actually say it will not default, but it ended up defaulting. So that is called as a false positive, and it is a type 1 error. And when we say false negative, it is like incorrectly predicting a negative instance. So you predict that it would default, but it ended up surviving. That's a type 2 error. So remember, we said that model says a person is guilty, but he was actually innocent. So he was models, the jurisdiction systems say that it is a guilty, he is a guilty, but he was actually innocent. So that's kind of a type 2 error. So these are the terms that you have to bear in mind. And these are the various performance metrics that are used in the confusion matrix. So to measure accuracy, what you do, you just in numerator, you have all the true results over, say, all the sums of the four things that we saw. So we saw these four things. In denominator, you have all four matrix, and in numerator, you only have the positive, true results. In denominator, true plus false result, irrespective of positive, negative. So that's the accuracy. And like if accuracy is this, then I would say error term is 1 minus accuracy. Okay. So this is something, there is one more term that has been given in the your literature. So you need to be, so, and the very important to note, accuracy plus error term would be always 100%. And precision focuses on the accuracy of positive prediction, and it is calculated as true positive over all the positive results. So when we say true positive, it is like predicting accurate result and which actually turned out to be accurate. And when we say false positive, it is actually you said that it will not default, but I mean you expected something positive, but that ended up having some negative results. So that is a type 1 error. So when you want to work on a type 1 error, it is a main metric that is being considered. So if you notice over here, precision is a valuable when the cost of false positive is high and we want to minimize. So when we say false positive, it means that type 1 error. When you want to reduce a type 1 error, it's a precision criteria that you would be mainly focusing. Of course, accuracy is important for all the models. But when you want to work on certain things, like in this case, if you want to work on type 1 error, it's a precision that you would be focusing on. And when we say recall, it's a true positive over true positive plus false negative. So when we say false negative, it's a type 2 error. Like you flag model flag something negative, but that was a false thing. The person was actually innocent. The negative model outcome indicated the negative thing, but I this was an actual thing. So that is in the denominator. Similarly, if you want to focus on type 2 error, it's a recall that you had to focus on. So this is some random example, training and validation. So there are two models. One is say logistic and another one is neural network. And we are testing training data. Training. This is a training sample and this is a validation sample. So prior to that, one video was made on machine learning, which clearly had overfitting, underfitting detail. So these terms are very well explained in that. Please go to playlist of cons. You will get that video. So say, for example, you have one model which is estimating default or no default, and which is a logistic regression, and another one is a neural network. Neural network is basically you just come backward. It's kind of how being a human, of course, for a default, it may not be that fitable model, but just for sake of understanding, just think that how the human perceives, how the human evaluates the default of the bond. In a similar way, we have trained our machine to get us decision default or no default. So that is a neural network. So the accuracy of this is a training data. So when you give some input, it is that kind of data. And when you try to validate, if you notice the accuracy goes down. So kind of some overfitting model, overfitting issue is there. So if you want to overcome that, there is a tool called regularization. So you can again watch the same video. It are the regularization, two types of regularization were explained in detail in that video. So of course, we can clearly see that there is a issue of overfitting here. Model is working very well for sample data, but when we are testing this sample for out of data, the accuracy is coming down significantly. So uh, overfitting issues definitely can be seen in this table. And precision, this is a precision for logistic regression, and this is for neural network. And for validation, again, it went down drastically. But yeah, better than recall. So in recall, for if you notice that for recall, it's improving. Like it was say 30 and 23% for trained data. For validation data, it increased. So over here, I would say there is a issue of underfitting, because for both data, it's not that well, but yeah, it has gone up for validation data. So this is how you can read different criteria. Accuracy in general is of course important, but when you are when you have to focus on type 1 and type 2 error, based on the things that you're focusing on, your criteria focus may differ, say precision or recall. So coming back to application of the knowledge, as we saw, there is a portfolio manager who wants to make a decision whether to invest private equity or not. So for him, it's a precision that would be he would be mainly focusing on, because there is a scope of type 1 error. So when we say type 1 error, if we say uh, the investment is not good, but we ended up concluding that investment is good, then there could be huge losses and we ended up having type 1 error. For type 1 error, it's a precision. If you want to cover false positive results, we want to uh, we want to decrease number of false positive error given by the model. So we would be mainly focusing on precision, and we would expect precision to go up. Likewise, a jurisdiction system problem over there, it's like more, it's for, we are morely focused on type 2 error. For type 2 error, the recall is a good fit for performance measurement, because we don't want model to produce false negative results. So that's something we would be focusing on. Let me just go back here. Yeah, so false negative, like model jurisdiction system said guilty, it's a negative result, but actual or empirical data, it was a innocent person. So type 2 error has to, this false negative results, we had to decrease. We had to increase, I mean, increase the accuracy for type 2 errors. When I say increasing accuracy on type 2 error, we had to decrease false negative. Eventually, we had to decrease, we had to increase or recall. Let me just go back, recall. Yeah, recall. If false negative, say for example, if these two are constant, just for sake of understanding, and if we decrease this, overall denominator is going down and the recall will go up. So the focus should be to increase recall, and for precision, we want to uh, decrease this false positive error, and eventually we want to increase the precision. So eventually we want to increase both precision and recall for overall model to be accurate. But if we want to mainly focus on certain things, like we saw over here, false negative, we will be focusing on increasing the recall metric of the confusion matrix. Hope you like the video. Yes, learning has no meaning if it doesn't create value for you. So at our institute, we ensure that we try to make you think so that you are in a position to apply your knowledge. So please do subscribe to our channel and comment if you have got any more doubts on this, or if you want us to come up with more videos on machine learning. So please do comment in the comment box. And thank you for staying connected to the end of video. Thank you.